My name is Robin. I'm the CEO and co-founder of Apheris, and what I'm going to show you today is how to securely analyze data of multiple parties while keeping proprietary information private. And for all the technical people in that room, so what we are developing is a platform for federated and privacy-preserving data science. Before I kick off, maybe a quick background on the company. So we are on a mission to fundamentally change how organizations collaborate securely and extract value from data. Company is growing very healthy. We've been founded in 2019, are today 17 people, very technical and scientific team, 60% has a PhD, and we've raised more than $4 million from leading European and US investors, including, for example, Patrick Pichette, the former CFO of Google and current chairman of Twitter, or as well Ross Mason, who founded MuleSoft and exited to Salesforce in one of the largest tech exits. And we partner globally and as well across industries, and have as well a strong commitment to open source. So the problem that we are solving is that organizations today often lack access to the right data and typically lose time and money in very complex compliance processes. So today we see if you want to collaborate on data with, for example, suppliers or customers, organizations spend millions of dollars via complex compliance processes. Often the data collaborations are strictly impossible. So then the data value is not unlocked. That is both within an organization, and for example, data is distributed across geographies, but as well across organizations when you want to collaborate on third-party data. And due to that, as data is not freely accessible, most data science programs fail today. Obviously, the usage of AI requires large and diverse data sets to be successful, and these large and diverse data sets are typically distributed across organizations. And so if access is not given, data science programs fail. There's an untapped opportunity for organizations, and that's gaining controlled access to high quality data that is owned by multiple parties. So what we are building is a world where a data scientist can start using third-party data that is distributed, while preserving the privacy of the data, or as well the intellectual property of it, and as well while being able to preserve the modeling IP that the data scientist might bring to the table. How that works is via the Apheris platform for federated and privacy-preserving data science that rests on two breakthrough capabilities. That's on the one hand, the idea of federation, and on the other hand, the idea of algorithmic privacy. So federation means that instead of centralizing data at one central location, we bring computation requests to the distributed data sets and then compute in their environment. And algorithmic privacy is the idea of basically bringing privacy into the computation itself and making sure that any information that is sent around or shared between companies is by construction privacy preserving. So I can quickly run you through our product from a workflow perspective. So we first of all offer the data scientist who wants to train, here in our case, his model on data of two data owners. We first of all offer him the so-called Apheris integrated development environment to make sure he can develop his computation requests. So there we're leveraging tools like synthetic data, virtual data, or sample data, and that allows basically the data scientist to understand what third-party data is indirectly accessible. Then based on that, he develops his computational request, sends it to the privacy guard, where we first of all automatically measure the potential leakage and then offer privacy enhancing methods to make this computational request privacy preserving by construction. Then the compute dispatcher orchestrates the computation within the environment of the data owners. So data is always under the full control of the data owners, and neither Apheris nor the data scientist has access to that data. And then via iterative federation schemes, you can train a global model on those distributed data sets. All training happens remotely. or locally. And then after the global model converges, we can then release the trained model to the data scientist. So in the end, the data scientist gets a global model that has been trained on the data of multiple data owners without ever touching the data, and via the privacy guard as well, with provable guarantees that he cannot reconstruct sensitive information that needs to be protected. What type of benefits does that serve for enterprise customers? So we enable organizations to securely analyze distributed data while preserving the privacy and intellectual property, and that means companies can save time and money by not running through complex compliance processes. The technology can be used to enter new partnerships with suppliers or customers, or as well with consortia, and ultimately build new data products, because the access to the diverse data increases the possibility to build new solutions. And we are in production with leading enterprise customers, including, for example, top 10 pharma companies. But our technology is as well used across industries, and these are typical industries, and we are active in. So pharma we started with, but we are currently addressing more industries, including automotive, manufacturing, insurance, healthcare, medical devices. So if any of that is interesting for you, and you want to unlock value from private data that is captured in third-party organizations, feel free to reach out to me, and I'm happy to help. Thank you.